I want to thank you, all of you, for coming. There's a lot of very cool sessions this KubeCon, so we appreciate you joining us today to talk about moving applications to production in Kubernetes. And what Gus and I are going to be covering today is about how to bridge that gap from when you just instantiate a cluster and you need to install all the different pieces to have a production environment, like monitoring and logging, certificate management, and so on. So a little bit about us. We both work for Bitnami. I have a background in open source. Then we have been involved in different projects for over 20 years each. In the case of Gus, OpenStack and Debian. In my case is Apache, as well as working a number of commercial open source companies, or Gus in his case, he spent over 10 years at Google. So a lot of what we're going to be presenting today is the evolution, or is informed by a lot of our experiences. The other part of our experience that has conducted us to work on the Bitnami's Kubernetes production runtime, which is the open source project that we're going to be presenting, is the experience at Bitnami of packaging a bunch of other people's software. We are one of the main contributors to the Helm project, and in particular to Helm charts. We also cooperated with Heptio in Jsonnet and with Microsoft on the recently announced CNAP project. So we have a lot of experience packaging third-party software so people can consume it. We have a lot of experience producing our own open source software that runs on top of Kubernetes. That ranges from small command line utilities to more like web-oriented or more end-user-oriented type of applications that you need to deploy on Kubernetes. And as well as we ourselves inside Bitnami, we are users and operators of Kubernetes clusters on at least 4 different clouds for multiple years. And multiple clustering in each one of these clouds. So we have gone through a lot of pain, and one of those is, and it's a recurring theme, is when you are packaging software for other people to consume, you end up writing a lot of probably like a third of your documentation is not how to operate or how to run the product itself or the project itself, but all the different pieces that need to be in place for the application or the project to run. And this is, for example, for our open source project, KubeApps, a lot of documentation on how to enable an ingress controller and TLS configuration. Very similar when you need to deploy WordPress as a Helm chart. So you see we start seeing a lot of patterns that repeat themselves, and that's not good. That's something that we wanted to fix, because it's a pain point for us and it's a pain point for a lot of other people. And this is the gap that I was talking before, is once you install or you get like instantiate a cluster on GKE or AKS or AKS or any of the Kubernetes service providers, is you need to build on top of that. There's a lot of things that need to be in place. It's typically not clear for somebody who is just new to Kubernetes what is the best monitoring solution or what people are using for logging. So it's, you need to do a little bit of Googling, a little bit of, asking or seeing what people are using. And then you end up implementing all this. It tends to be like very manual. It tends to be different for different people. So you have all these variations of how, the basic same components are installed within the same organization sometimes, or definitely within different teams and different companies. So what we have come up with is, and this is a solution that we want to present today, and we'll also mention at the end how other open source projects are solving this, is what we call the Kubernetes production runtime, which is a standard set of manifests that give you kind of the basic building blocks that everybody expects, like monitoring and logging, ingress controller, certificate manager, all the very basic pieces, and nothing else. And we do it in a way that it just works out of the box. Like if you don't know, what you should be installing, you just execute one command, and we give you all these different pieces working together. But, and this is a very, very important but for us, and this is where Gus being here, a control freak, helps out, is we make it super, super easy for the administrators to customize that and specify that delta to make it work exactly as they want. So it's kind of batteries included, but we make it super easy, and that was one of the original design goals for people to customize it. We don't have a lot of time. I wanted to give a live demo, but the closest that we can do in the time that we have is I recorded a video in which it shows in a minute what this looks like. And what you're going to see in the video is how we can deploy a Helm chart. This is KubeApps, is another open source application that we maintain, but you can deploy the same Helm chart using the command line, and the result is going to be the same one. We're going to be deploying WordPress using a Helm chart. We give it a name, and then specify in the options that we want, the domain name that we want for the WordPress blog, as well as we want an ingress controller, we want SSL certificate, and we want monitoring. And just with that, once the WordPress chart gets deployed into the cluster, it's going to be automatically monitored, so the application is running. You can see that it has a valid certificate through license script automatically without having to do anything. The application is being monitored, so you can go to Prometheus and start taking a look at the metrics. In this case, is access log for the visits to the website, as well as with Kibana, you can take a look at the access log for HTTPD or any other queries that you may want to do, like taking a look at the different containers that make the deployment. So this is an overview of what you can do once the system is in place and is installed in the cluster. You can launch an application, and with basically little or no modification, the application is going to be monitored and secure and certificate managed and so on. Now I'm going to let Gus tell you how we implemented this and how you can use it.
Hey, good morning, everyone. I'm an infrastructure guy. I've spent my whole career working as a programmer and a sysadmin, and the sort of combination of both those things. And so when we set up our cluster internally, we wanted to provide the standard services to our other developers. And so we went on this journey where we, the same thing we've all done. We went and we installed Prometheus and we set it up, and we set up Node Exporter and Alert Manager, and we configured these things to talk to each other, and we went and got ElasticSearch and Fluentd, and then we realized that the standard upstream ElasticSearch add-ons don't work very well, and they don't survive upgrades very well, and so we went through and we debugged that and we fixed that, and we had to become instant experts in ElasticSearch and Fluentd and Certificate Manager, etc. So we got it all working in the end, and we're pretty happy with the result. But this was not what we wanted to do. This is not our core business. And this is the same for everyone else here, I'm guessing. No one wants to innovate based on how they set up Prometheus. So what we want to do is just through this project put together our findings, our results, and make it in a way that everyone else can consume, and so we can just stop repeating the same infrastructure lessons. So this is a collection of our best practices that we've found as we've been using these for a few years, and it's these standard stacks that everyone needs to install. Deliberately very conservative choices. If you look at this list, there's no surprises there. This is all the stuff you would set up yourself by hand anyway. Unlike some of the upstream examples, we're defaulting to production. So we default to N+1 availability, we default to RBAC enabled, we default to persistent volumes, all the things you would want for production. So you should just be able to take this out of the box and run your real production clusters using this setup. That's our goal. The way we go about this, we've effectively put together a project that has three parts. There's the de facto specification of what an application can expect, like how does an application interact with this. And that's all the standard ways. If you want your Prometheus to scrape your pod, you put the standard scrape equals true annotation, the same thing you do normally. So we've kind of standardized those things. If you use BKPR, if you're writing an application that targets BKPR, you can just assume that it's going to follow that standard. Then we have a bunch of manifest templates. That's the real main export from this project is the manifest templates that describe what's going to be installed. And then to make it easier to consume, we have a simple installer tool that just runs all that for you automatically with a single sort of command line. We follow the Kubernetes support model, so we support 2 consecutive releases. At the moment, with the 1.0 release of BKPR, we're targeting AKS and GKE clusters, but obviously EKS and Amazon COPS are hot on our list for the next couple. And then after that, we'll just follow demand. Whatever people want to see, we'll try to support. All Apache 2 licensed, all available on that GitHub project. And yeah, so those 3 parts, so the installer, the manifests, and the de facto specification. So the install experience, here's the simple installer. I'm going to come back later on and show you the more flexible version, but the simple experience, start with a fresh cluster. Whatever you get off GKE or AKS or the future supported platform, start with the empty cluster. You download the tool, you run the tool with some command line flags, and then magic. It configures the DNS for you, it sets up the service accounts for you, and you can just use it. So you can go to the various consoles we provide, Kibana, Prometheus, Alert Manager, these sorts of ones. They're all provided over TLS. We configure the DNS names for you. They're all OAuth protected. So you have to sign in with OAuth credentials on whatever your relevant cloud is. So AKS OAuth or GKE, Google OAuth, and it works. And when you want to do an upgrade, you come back, you download the new version of the tool, and run it again on the same cluster, and it'll take you to a new version of the manifest and do a clean upgrade. So just expanding on those, what really happens, the installer tool goes and does a lot of non-Kubernetes setup. So it sets up service accounts, sets up service principals, it generates passwords, and then it stores the result of that in a little JSON file, and then that JSON file are basically your cluster local parameters. So we get those cluster-specific parameters, and we combine them with the standard manifests, and then that generates the actual YAML objects for your cluster. And then when you come back and do an upgrade, the upgrade reuses that same JSON file, and just sort of like Terraform, it'll fill in any blanks. So if the new version needs some extra cloud resources that aren't in that JSON file, then it'll go and create just those missing pieces. So very similar to sort of Terraform approach. Now, is that same thing in a diagram. So we've got that JSON coming in and then the templates coming in. They go through an engine called Jsonnet, which I'll talk a little bit about later. Jsonnet is a small language. It's really good for manipulating JSON. It's really good for getting JSON in and manipulating it and then spitting out regular JSON in the result. Now, I'm guessing, as an infrastructure guy, I'm guessing all of you, as soon as I said, a magic installer, you all just went, yeah, I'm done, I'm not using this tool. So, let me tell you how I expect you to actually use this in production. That the KubeProd installer is good for demos, it's good for quick trying this out in your cluster, but none of us, obviously, are going to run a black box and trust our infrastructure to a little black box tooler. So, let me come back to this diagram again. As I said, the installer does some non-Kubernetes stuff and it writes a JSON file with the results. If you have a complicated setup, if you have multiple clusters, if you use a strange OAuth setup, if you, like us, we have various internal projects and approvals and things, so there's no one really who can just run a simple installer. So you can do all those steps by hand. There's not a lot of steps there, just have to create the service accounts, and get the various IDs and store them in this JSON file. So you can create that JSON file however you want. You can use Terraform, you can use internal processes, you can do it manually, whatever you need to do for your particular situation. Then separately, you get the templates. You can use a tool kubecfg, which is from the Jsonnet project, which can consume those Jsonnet templates that are exported by our project and smoosh them together with those JSON parameters, and you get all the YAML objects. And you can look at that YAML, you can diff it versus your live cluster, you can have a look at what's going to happen there, you can see exactly what's going to be created. And then you can either push that directly using kubecfg, or you can store that YAML on disk, you can do whatever you need to do, push it through your existing workflow using kubectl apply or various other GitOps tools, whatever you currently use to do that, you can do that with this. Okay, this is how I expect it to actually be used in production, right? You don't trust some little installer tool. You want to see the pieces, you want control, you want visibility, and you need to be in power for the whole process. So the advanced version, do it by hand. This little JSONnet overlay is really what merges the parameters and the templates together, and it looks like that little chunk down the bottom there. So you can see it's importing the templates with the version and the platform, and then it's getting the local parameters JSON, and that provides arguments effectively to those templates that then get expanded by JSONnet. What JSONnet allows you to do is put any other override you like in that same little file there. So using the JSONnet language, you can change anything that gets installed. You can say, I don't want ElasticSearch. You can say, I do also want Istio. And you can configure these extra pieces in there. You can remove those other pieces. You can modify any parameter anywhere. And then the result can get generated into regular objects that then gets pushed into your cluster. You have full control over what gets installed. If you really want to, you can, if you were an infrastructure team for a larger company, you could take this, you could provide some overrides, an overlay for your particular company and your particular conventions, and then you could re-export that. You could say, hey, application teams, you can now take the result of this, and you can then apply it again in your own clusters. So you can have chains of overlays effectively and customize this again and again and republish again and again, depending on how it fits your organizational structure. So this is a slightly odd idea where we're trying to do standardization, but we also want to provide flexibility and control. So the general realization, I guess, was that in practice, in theory, this is unsolvable. In theory, this is ridiculously complex. But in practice, it's not. In practice, people do very simple overrides. Like me, I have a cluster at home that is mixed architecture. I've got a couple of Raspberry Pis, I've got a couple of old AMD laptops, mixed architecture. I can't take any standard Helm chart and use it because I need to add a node architecture restriction that says only run this on AMD 64 or only run this on ARM. And no one ever thinks of providing that as a parameter. But with JSONnet, I can override anything. I can provide that one parameter, and I've customized it in a way that the original author didn't intend, but it's a very simple customization. It's very simple for me to carry that customization forward over future versions. So in theory, this is a big complex problem. In practice, it's really simple. So our kind of social contract here is we're going to test the base manifests together. We're going to test them on the various platforms. We're going to say these all work together, and we verified that. And if you want to do any overrides, that's on you to test those overrides. But in practice, that's actually really simple in most practical cases. And then you can carry that overlay. You can carry that forward across future versions quite simply. And then all you have to do is re-expand the YAML and make sure it does what you want and verify the result. And then when you're happy, push it to your cluster. Here's an example. This is JSONnet syntax. Looks a little bit like JSON. It's got some extra pluses. The plus means merge it in with the parent object, merge it in with the template. So this is my contrived example here. I'm getting the Nginx ingress controller and I'm multiplying the grace period by 2 for some reason. Contrived reason just to show off that I can do mathematics in here and I can refer to the parent object if I want to, and lots of other things. It's a whole mini language. You can look at the jsonnet.org website to see some pretty good examples. It works very well with Kubernetes because there's a lot of duplication in Kubernetes objects, and this language we find really, really powerful in working with that. And it's the basis for the KSonnet tool and the kubecfg tool. They've both chosen to build around the JSonnet language. All right, so obviously this is just one part of a big workflow, and we deliberately don't want to be those other parts of the workflow. We just want to handle the resource template part, that standard infrastructure. At the end of the day, it just produces regular Kubernetes manifest, Kubernetes YAML. So you can use this with any other tool. In practice, you would want to wrap it in other tools. You want to have some sort of Jenkins or Git or whatever to store the configs that you've got, version them, and then eventually to push them to your cluster. For application management, this works with all the standard applications. You can use Helm, you can use KSonnet, you can use kubeapps, you can use all these other tools. They all work just fine with it. I felt bad putting this slide together because I've only got a few logos on here, but this is like everything. Everything in the ecosystem should be on this slide here because this is just what you would do yourself normally anyway, and so it works with all the other tools, just as it normally would if you had built it yourself. One that deserved a special dedicated slide is Knative. Knative has a lot of overlap with this project, the green bits there. That's really because everyone wants these same stacks. And Knative, just like everyone else, wants to have these same stacks, so they duplicate some of the pieces we have. You could install Knative and BKPR into the same cluster. It'll work fine. It's a little bit of a waste because you'll be running 2 Prometheuses. You'll be running 2 Elasticsearches. It'll work fine. It's just wasting some resources. So right now, if you were to do that, you would want to provide an overlay that turned off those duplicates. And that would be okay. If I had to summarize the 2 projects, people ask me what's the difference. So if I had to summarize the 2, I'd say Knative is quite opinionated. It's quite advanced. It's bringing not just monitoring and logging, but it's also recommending a way to develop your applications, a way to roll out your applications, a way to build them. It's a lot more bolder in scope. Whereas what we're trying to do is much more conservative. We don't want to recommend a new way of doing things. We don't want to get into how you develop your software. We just want to say, no, basic infrastructure that we don't want to innovate on, we don't want to experiment with. It's just the boring bits. So if I had a magic wand, we could merge these 2 projects somehow by getting Knative to reuse the BKPR templates for that common part. And we might actually explore that in the future. So then Knative would be BKPR plus an overlay that added the Knative special magic. That would be a reasonable way to unify these 2 in the future. So Knative is much more advanced, much more bolder. It's recommending ways to develop your software, whereas BKPR is just providing infrastructure, and we're designed to be a base that other people can build on, if you like. All right, so that's the end. We have really what we're trying to do is just provide basic infrastructure for everyone that we can all agree on as a community and we can all reuse as sysadmins, so we don't have to relearn how to do this stuff. We don't have to learn what to install. We don't have to learn how to install it. As application providers, we no longer have to talk about maybe you're not running Prometheus. Maybe you haven't got TLS enabled. We can just assume that there's always going to be ingress. There's always going to be TLS. We can always have security. We can assume that RBAC is always there. So we're just trying to provide a slightly higher level standard for Kubernetes. So instead of just deployments and daemon sets, we can say deployments and daemon sets and TLS and Prometheus. And then we can all just kind of raise the water level just at slightly higher and start thinking about more interesting problems instead of how do I deploy Alert Manager. That's it. So we'll be around. If you want any questions, we're around at the Bitnami stand for the next couple of days. You can go to kubeprod.io. You can download it, try it out. We don't have a dedicated Slack channel right now, but the #GitOps one on the Kubernetes Slack channel would be a reasonably on-topic channel if you wanted to discuss any of this. And yeah, got any questions you could probably ask me. We've got a little bit of time.
Yeah, and then the thing I want to mention is we are working right now on EKS support and a few other platforms. So we just released the project. Right now we're looking for a lot of feedback. So if you just want to try it out and give us feedback, that's really welcome. Even more welcome our contributions and pull requests and helping to port to some of the other
If you want to use it, if you want to use it in a different platform, then let us know and that'll help steer our priorities. More importantly, if you don't want to use this for some reason, also come and talk to us and let us know what that reluctance is about. And infrastructure guy, I totally understand not wanting to give up control, which is why that was such a big part of this. So I'd like to talk about feelings too. If you feel you don't want to use this, that's also an important thing that we should talk about. So yeah, thank you very much.
Awesome, thank you.